Hey everybody! Recently, while working through a Kaggle competition, I was struck by a challenge of loading a large dataset into memory. Well, effectively, Pandas loads the entire data frame into memory, thus causing memory bottleneck. So, in this video, we are going to talk about three tricks using which we can effectively load a large dataset into memory using Pandas. But before going to that, we are going to discuss about a very different data type in pandas, which is also the most least talked about the data type, the category data type. I'm sure most of you have worked with categorical attributes in data frames. So as you must be aware that categorical types in pandas are by default considered as string objects or the object types. Now, one of the challenges with the object types is they occupy a lot of memory space. Also, the second challenge is there is no relative ordering between these objects that are stored in the categorical type, in the categorical attribute. On the other hand, when we talk of category data type in pandas, it provides you with memory efficiency. At the same time, it provides a logical ordering. So, say for example, you have three categories: small, medium, and large. Now, you can specify a logical ordering for these three categories in your category type. And when you perform any operations such as sorting or min max, pandas will internally understand this logical ordering and use it for such computations. Let us head over to the documentation and read more about it. So if you see, the category type, it considers two primary attributes. The first is the categories, which are finite discrete category levels, and second is the ordering. If you specify the ordering, it determines the logical ordering for those categories. Okay, now you understand that this particular category type can help us save a lot of memory in term and provide a computational efficiency when the number of categories is much less than the actual length of the attribute. Say for example, if your attribute is having a length 100 and you have three categories, then category type is a much better option as compared to the default object type. Now, coming back to our question of what are the three tricks using which we can make our memory more efficient for our pandas, or in order to load larger data sets into memory using pandas. So, the first technique is using efficient data types. What we mean by it is here, so by default, pandas will load numeric types as int64, float64, or categorical types as object types. So instead of loading them as int64, float64, which is occupying here larger 8 bytes of memory, what we can do is, if we see in reality, like say for example, if you talk of an attribute named age. So age in general for a human being could range from 0 to 100, or at max say 120. So how many bytes of storage do you require for each such value? I'm sure you must be familiar that or just one single byte would be enough. One single byte is enough to store 256 different levels here. So storing 0 to 100 or 0 to 150 in fact could very well be carried out in just a single byte of data. So why should we use 8 bytes of data in its place? So therefore, using efficient data types in place of the default data types could help us save a lot of memory, and it provides much greater flexibility in terms of the memory efficiency. So the second type that or the second trick that we are going to use is chunking. So pandas, when you load any data frame from say CSV file, TXT file, it allows you a parameter called chunk size. Let us see pandas read CSV parameter. Okay. So in this method, we will see a parameter named chunk size. Let us head over to that parameter. Just a second. Where did we had this? Yes, see. So here this chunk size. So upon specifying this chunk size, it will allow you to load as many number of records at a time as you would consider. Say for example, you want to record only 1,000 rows at a one load, okay, for per single row. So it will allow you to load only 1,000 rows at a time. It will generate an iterable using which you can iterate over all the rows in your data frame. So this again allows you flexibility in terms of your memory usage. However, note must be taken that any operation carried out on a chunk must be independent of the other chunks. Otherwise, it will create certain ambiguity. And third, which is almost common, is drop the features which are least useful. Even like dropping certain attributes from your data frame which are not very useful could lead to saving a lot of memory for your data frame. Okay, so using these three tricks, I hope you would next time be able to load or manage your memory more efficiently when you are dealing with pandas. Remember, whenever any transformation is taken on a data frame in pandas, it usually creates a copy of the data frame, thus leading to more overhead. So what what various people have done over the years is they have designed various tools around it using the concepts of multiprocessing, multitasking. One such popular tool is Dask. Let me know in the comments if you have used Dask before and where you have used, what are the advantages of Dask that you have come to know across. See you in the next lecture. Have a nice day. Don't forget to like, share, and subscribe. Jai Hind. Bye bye.